All right, ladies and gentlemen, today we're going to look at understanding prime and composite numbers. First of all, our objective is that all students will be able to learn the difference between a prime number and a composite number. This goes with standard 6.NS.6, identify and explain prime and composite numbers. Here we go. First, we've got to look at some academic vocabulary terms, knowing the difference between a factor, a prime number, a composite number, and then, of course, the introduction of prime factorization. So first, we want to look at factor. A factor is a whole number that can be multiplied with another whole number to make a product. And as we can see up in our example here, we have 6 times 7 equals 42. Two whole numbers multiplied together to equal a product. That's what a factor is. Once you know what a factor is, we can better understand prime number. A prime number like these that you see up here, 2, 3, 5, and 7. A prime number is a whole number with exactly two factors, the number 1 and itself. So if we think about this number 2, 1 times 2 equals 2, and those are the only two factors. 1 times 3 equals 3, and those are the only two factors. Why didn't we do 4? What other factors does it have besides 1 times 4? That's right, 2 times 2 equals 4, so it actually has more than two factors. Which brings us to our next term. Anything that has more than two factors is what we call a composite number. A whole number greater than 1 with more than two factors. So when we look at our composite numbers over here, we can see 4 has 3 factors, 1 times 4 and 2 times 2. The number 8 has more, it actually has 4 factors, 1 times 8 and 2 times 4. What other factor does 9 have besides 1 times 9? Great, 3 times 3. And we could keep on going to find out all the factors, but one pattern that I notice, we have 4, 6 is actually also a composite number, 8, 10, 12. Will you ever have another composite number that's, will you ever have a prime number that's even besides the number 2? The answer is no, because all the other even numbers are going to have 2 as one of their factors. So 2 is actually the only prime number. Now, the only even prime number. Moving on to the next one. A prime factorization is a composite number that's written as a product of prime numbers. And here we actually have it in exponent form. But all of the factors that are making up the product 200 are all prime factors. 2 is a prime factor, 5 is a prime factor. Now let's take a look at some examples. How can we determine if an answer is prime, or if a number is prime or composite? Yes, we can use the divisibility rules to help us. And here we have our divisibility rules. A number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. So let's look at an example. Is 153 prime or composite? If it's composite, we know that it's got more than 2 factors. If it's prime, it has exactly 2 factors. Let's try the divisibility rules. Is it divisible by 2? No, because it doesn't end in a 0, 2, 4, 6, or 8. Is it divisible by 3? Well, if we find the sum of this number's digits, 1 plus 5 plus 3, that actually equals 9, and 9 is divisible by 3, so that tells us that it has at least the number 3 as a factor, which means it has more than 2 factors, and it must be a composite number. Let's look at the next example. 29. Is it divisible by 2? No, because it does not end in 0, 2, 4, 6, or 8. It ends in a 9. So we move on to divisibility by 3. Well, if we find the sum of the numbers digits here, we have 2 plus 9, and that equals 11. 11 is not divisible by 3, so 29 is not divisible by 3. Does it end in a 0 or a 5? No, it does not. We could even go on to the next lowest prime number. If we look back at our previous screen, the next lowest prime number was actually, if we look here closely, a 7. So if we look at this number, 29, is it divisible by 7? No, because 7 times 4 is 28, and 7 times 5 is 35. So 7 does not go evenly into 29. And then we can conclude that 29 is indeed a prime number. Its only 2 factors are 1 and 29. Here's some practice. Let's try this one. It's not even, so it's not divisible by 2. But 5 plus 1 is 6, and 6 is divisible by 3. So this number would be composite. Try the next one. Pause the screen. Think about it. Did you come up with composite? Yes, because it's an even number. So it must be divisible by 2. How about this number? Pause the screen. Did you come up with composite? Because it's divisible by 5, it ends in a 5 or a 0. This one is prime. When we test our divisibility rules on this one, it's not divisible by 2, 3, 5, and if I move on to 7 and 11, it's not divisible by either of those either, so it must be prime. How about 24? That's right, it's an even number, it's composite. 47? That's right, it's a prime number as well. And 56, yep, it's an even number, so it's composite. Well, I hope this helped you out with understanding the difference between prime and composite numbers. See ya!